It is sure that Fusion 360 is good for mechanical part design. We have learned many key strategies to design a mechanical part and also modify it when needed. But Fusion 360 is also great for some more functionalities. One of them is assembly. Assembly brings up a vast opportunity to describe the placement of machine components in a machine and also their degree of freedom. In this lesson, we will learn some of the key functionalities for assembly design. To understand the assembly environment well, you have to understand the difference between components and bodies. Components are the elements of the assembly that makes this assembly successful. Something like a screw of a machine or a arm of a machine. Those are the components of the assembly, the machine. But bodies are the elements of the components. Those are created to consist this component and make this workable. One or many components makes a assembly and one or many bodies makes a component. So in here you can see that our browser is showing that here is a icon for component. That means Fusion 360 is having an component, single component in this interface. It is not an assembly yet, but you can see there are many bodies and these bodies are individual, different from one another. So I can declare them as a component, these bodies as a component, so that this interface becomes changed in assembly. So I am making this body as a component by right clicking and selecting create components from bodies. So you can see there is a component is created, a new component, and the icon is changed to assembly icon. So we are now in assembly with one component only. So I can right click and do the same with the other bodies, and these are now components. So I have successfully transformed this component interface to a assembly interface. We are now in a assembly, and each on and every of them, the elements you can see in the screen are the same, but they are now not bodies, they are components. What is the advantage of this? The advantage of converting these bodies to components is to start off declaring the assembly. You can declare the degree of freedom between these elements with each other, and also you can make drawings and working videos, and also you can check that how they will perform as a assembly. So what I can do now is that I can drag this component without using the move copy command. I can just mouse click the drag and turn it outside. There is no relation between them. So why I can move them? Because they are now converted into components. If they were converted into bodies, I couldn't move them. So how to make this assembly happen, or how to make this arrangement happen? So for this you have to take a stationary part, that part that will be fixed in assembly. Like in a machine, there is a fixed portion of your machine. In every machine you can see, like you are using a lathe machine, there is a bed of the machine. The bed is always fixed. The platform on which the machine consists of is always fixed, that's not moving. So you in this part there is also moving fixed part. So I have to fix one of the platform, which is this. So how I can fix a component by not moving it? I just go to the component list and find that component. Here it is. So I right click on it and select ground. It is now grounded. I can't move it. I can move the others, but I can't move this because it is grounded. Now I can apply the joints to make the movement as I want. So I'm going to show you some joints now. Here in the assembly you can see some new components. You can create the new component, a new component that is not existent, and some joints. So I'm clicking on the joints, and now I'm in the join command. In this join command you have to select component 1 and component 2 in which you are applying the relation one by one, and then you will apply the type of motion. There are some types of motions in here. So such as I am selecting component 1 as this and component 2 this. What happens is that snapping the points make them together or coincident. What that means, I am cancelling this and doing this again. You can see there I can snap the points. If I zoom, you can see I can snap. When I am selecting the components, I can snap a point. It is the middle point of the cylinder or the first end or the second end, whichever, but I can snap any of the points, not the body or anything else. I have to snap a point. So as a motion we are selected as rigid. So I want this point. What I want to do, I am selecting this point to be coincident with this point, and the motion is rigid. That means they will be rigid, that this won't be moving according to this phase. So I'm okay with that. So this is also rigid now. Same, I'm going to apply the rigid joint in here too. For component 1 I'm selecting this, and component 2 I'm selecting this, and they are rigid. Again I am applying the rigid joint for this and this face and this point, selecting OK, selecting the rigid joint. If I want to move it, it won't be moving, so I don't need to apply in the fourth point that it is rigid joint. It is already rigid. So the whole thing in here I have created in a rigid joint, and it is not moving, it is just fixed. Now I am applying something that will be in the position, make it in the position, and also make it movable, not rigid. So how I can move it? So I am going to join command, and I am selecting this middle face, and also selecting this middle face of the cylinder. I hope you can see this middle face. So that is positioned. Firstly, that is positioned. Now what I can do is, there is a joint type that is revolute. What that does, that gives it a degree of freedom to just rotate. So I am clicking revolute, and it can animate me. It's animating. You can see the animation, you can see it again. So that it only has 1 degree of freedom to revolute in that point. So that is a good representation. I am selecting OK. So when I am selecting OK and see the representation by dragging, you can see it can only move in one direction, and it is rotational direction actually. So it is moving through the axis. Similarly I am doing for this also. I am selecting the midpoint, that I want this point to be mated with this point. So I am having a trouble selecting the midpoint in here, right? So how I can select it? There are too many points in here. So you go to the face, select, press the control key of your keyboard, and select the point. When you select the point, it is automatically selected, and you can see it is now moved. So that's how you can select the point. If you are not grabbing it, just hover over the face and press Ctrl and then select the point. So that's how you can put this thing in the position. So we have done this assembly, you can see, and it is working fine. We have created our first assembly. So rest of the motions in here we have seen rigid and revolute. There are some other options we can apply. Suppose let's just delete these rigid joints and so on. Now I am going to show you what is the function of cylinder joint. So these, as I deleted the joints, they can be moved now because there is no joints. As I grounded this component, it is not movable right now, but this component is movable. So what I am going to do is to go back where it was, okay, and make this component grounded also. So these two components are grounded, but as I applied the joints before, they are aligned, so they are perfectly aligned. Now if I want this cylinder to be moved, not just only fixed in this point, I just want it to be moved cylindrically, by axially actually. I want to move it axially. How I can move this or make this relation happen? So this happens by the cylindrical joint. So I select this point or any point of the cylinder and select another point of another cylinder, and I go to the motion and select the cylindrical relation. What that does, that this cylinder can move axially and also move in the rotary motion by its perpendicular to its axis. So let me show you. It can move, and you can see that I can rotate it also in its own axis, and I can also move it linearly regarding to its axis. You can also put a value in the degree if you want, so that's up to you. You can put a value of 90. So that's a good thing, that you can put value and make things in a position that you want. So that's the cylindrical joint. So these three joints actually makes thing easier for you. You have also pin slot joints. Those are very much special cases. Planar joints, ball joints, and slider joints. Those are for the advanced machines, and you can apply them in the intermediate states. So I'm not going to show you those. You can apply these three joints and make your simple assemblies complete. So that's how you create the assembly environment, and I am going to show you once again how that will be created. So I'm Ctrl Z and making this relation gone, and now I am just establishing the same thing, joints here, here, and this rigid joints here and here. It is rigid. That's the point we have, and that's the point we want to get, and then we select the revolute. Perfect. And this one I'm selecting this point, and so I am having trouble. What I can do, I select the control, I press Ctrl and select the point. So it is now selected. So how you can analyze the movement of your components in assembly? Suppose I am moving this, not acting like how it should in the real life. So how you can check that they are not in the collision state? So here is an option you can establish, which is called contact set. You go to the contact set and select the contacts you want to check and then select OK. Now if I move, you can see the other one moves as they collude, and it is a nice way to check that if you are having collision between two components or not. So that's how you can check your assembly for its movement. So that's the basic for assembly environment. I hope you practice a lot for the joint and creation of the assembly, and you understand the difference between components and bodies. Thank you.